Okay, the coordinates of the points P and Q are 3, 6 and 15, 11 respectively. Alright, and then part 1 says calculate the length of the line PQ. So if we think of P as our first coordinate, okay, so if I call that like my x1 and then my y1, okay, and then we can think of Q then as my second coordinate, so we call that x2, y2, okay, then we can work out the distance between P and Q, in other words, the length of the line, yeah, that joins P to Q, okay, that will give us the distance by using the formula which you've learnt from Pythagoras' theorem, okay, and that goes like this. So you've got square root of x2 minus x1 all squared plus then y2 minus y1 all squared. Okay, so that's something that we need to learn, memorize. So in the bracket, okay, ensure you use brackets. You do the x2, which is 15 to start with. Take away then the x1, which is 3. Close bracket, square. And then the second bracket then, my y2, which is 11. Take away then my y1, which is 6. Close bracket, square. And square root the whole thing. Now, because this is a calculator paper, we can do this then on a calculator in one go. So square root, okay, just follow what we've got here. Get that on the screen, so bracket, okay, close bracket squared, and then add, and you get the screen looking exactly what you've written down, okay, and you press equals, and it comes out to you straight away as 13, okay, and you're allowed to do that. You don't need to do any other show any other workings here. You can go straight to the calculator. Find the gradient then, it says, of the straight line perpendicular to PQ. Okay, now notice that there it says perpendicular. Okay, that's really important. Okay, but the first thing you do is you work out what the gradient of PQ is. Okay, so the gradient PQ. Now the gradient formula, if you remember, is looking at the difference in y's divide by the difference in x's. Okay, so it's like the old idea of rise divide by the step. Okay, because you get the gradient then. So in this case we just use the values we've had before, okay, up here, because it is P and Q, isn't it? So we've got my y2, which is 11, take away my y1, which is 6, all divided by then x2 minus x1. So my x2 is 15 and my x1 is 3. Okay, now I could work that out in my head, but because it's a calculator paper and I want to make sure I get it right, why not just do it straight in the calculator so you don't have to think too much, okay, and we know it's spot on then, so you can type exactly as you've got it there. So press the fraction button, okay, and in the fraction button we put 11, take away 6 on the top, press the replay button then, press down on that, and then we can put 15, take away 3, and we get our answer then to be 5 over 12. Okay, now remember the gradient of PQ is 5 over 12, but we want the gradient of the line which is perpendicular to PQ. So to get the perpendicular gradient, okay, remember we've got to use that rule, m1, m2 equals minus 1. Okay, and what you're doing is, right, if I just draw a sketch, you're essentially thinking of two lines there that are perpendicular to each other. Okay, and what we mean by perpendicular, we mean at right angle to each other. Alright, so if the gradient of one line is m1, we call it m1, the gradient of the second line is m2, and then we've got this rule, okay, which always applies, and you need to remember it. When you times the gradients together, it should equal minus 1. Now the gradient of PQ, right, is 5/12, so we can think of m1 as being 5/12, okay, as we just worked it out, and we put it in here, times then m2, and that will equal to minus 1, okay. So I use dot for times, right? I often use dot for times. So we say m1 times m2 is minus 1. Now there's lots of ways of now working out m2, but one way we can think of this as simply 5 divided by 12, yeah? So if we take the 12 over first, okay, now think about it, because we're dividing by 12, so if I take the 12 over, I'm timesing by 12. So I'll have minus 1 times 12, which is minus 12. And then because I'm timesing by the 5 here, take the 5 over and divide. And what we have as our answer then for M2, our gradient which is perpendicular, if you notice, right, it's like the reciprocal of this, or the negative reciprocal, yeah? So it's the flip of it, yeah? So if that's 5/12, this is going to be 12/5, but a minus in front of it, so it's the negative reciprocal. Part B then, it says, find the equation, right, so completely different now, part B, find the equation of the straight line which passes through the point 0, -3 and is parallel to this line. Now, to get the equation of a straight line, we need a point that it goes through. We've got that there. And we also need the gradient. But the good thing is, it's telling us here that this line that we need to get the equation of is parallel to this. That means it's got the same gradient as this. Okay, because if it's parallel, don't forget, parallel means going in the same direction. So we've got two lines going in the same direction. If we get the gradient of this, then we'll have the gradient of our new line. So to get the gradient of this, I need to rearrange it so I've got it in the form y equals mx plus c, if you remember. So if I change this around, now because there's a minus 5y there, I'll take that over. So I can rewrite this as 2x plus 8 equals 5y. Okay? And, you know, taking that over becomes a plus. And you might prefer to just write it like this now. So we write it the reverse. We've got the y on the left-hand side. And then to get y equals, like you got here, y equals mx plus c, we need to take the 5 over, don't we? And if we take the 5 over, if you think about it, 5 times y, well, if we take it over, we need to divide by 5, don't we? Okay? And when we divide by 5, remember, we've got to divide each term by 5. So we could split that up, and we get 2/5 x plus then 8 over 5, right? So we can divide each term by 5. And that's my gradient. The gradient is equal to 2 over 5. So when it comes to the equation then, the equation of my new line, remember the equation formula, y minus y1 equals mx minus x1. Okay, well, my point, remember I said we need a point, is here. So my y1 is that, and my x1 is this. Now y1 is -3, so I put -3 in here. 2/5 is my gradient, and my x is 0. x1 is 0, so that's good. And when I've got this here as a gradient here, what I would do is I take that 5 up. That's what I would normally do, take the 5 up, and then I times the 5 by all of this, yeah? Now all of this becomes y plus 3, of course, because 2 minuses make a plus. And on the right-hand side, and I've just got 2, and it's just x, isn't it? Because that's 0. And then multiply out, so I've got 5y plus 3, plus 15 times by 5 equals 2x. And then get it in the form, so I've got 2x, take that 5y over, minus 5y, take the 15 over, it's got minus 15, so I've got it in the form ax plus by plus c equals 0.